Welcome back. Stereoisomerism can be very tricky. We've already talked about constitutional isomers. We've talked about enantiomers, which are non-superimposable mirror images. But we alluded to a third class of isomers, which are called diastereomers, and those are what we're going to talk about today. So if we start looking at compounds, most of the compounds we've talked about so far contain a single stereocenter. So for example, if we look at 2-chloropropane, it can exist as two enantiomers, right? You can have the R configuration, you can have the S configuration, or you can think about it as chlorine is up, chlorine is back. These are enantiomers. We're already familiar with that, okay? The situation gets trickier as we start adding more stereoisomers, okay? For example, what about this compound? First, what you want to do is ask yourself, how many stereoisomers are possible? A good way to get at that is to identify the stereocenters. Now we have two stereocenters, right? So it turns out that we have 4 possible stereoisomers. One where chlorine is up and OH is up, one where chlorine is back and OH is back, one where chlorine is up and OH is back, and one where chlorine is back and OH is up. I'll show you those on the next slide. Okay, so let's reference this compound. I said that there's 4 different stereoisomers that we could have of this compound. We could have one where chlorine is up and OH is up, or we could have one where chlorine is back and OH is back, or we could have one where chlorine is back and OH is up, or we could have one where chlorine is up and OH is back. Now, if we assigned RNS configurations, what we would see is that these two compounds differ in all their RNS configurations, right? Chlorine is priority 1, 2, 3, so this would be an R configuration. This would also be an R configuration. In contrast, this would be S, S, this would be S, R, and this would be R, S. These two compounds are non-superimposable mirror images of one another. So these two are enantiomers. Similarly, these two are enantiomers. What's interesting, though, is to compare these two compounds or these two compounds. Notice that these are not non-superimposable mirror images, but they are stereoisomers of one another, right? We have up, up versus down, up. So this stereocenter is the same, this one is different. So the relationship between these two, we're going to call that relationship diastereomers. And the definition is essentially going to be stereoisomers that are not enantiomers. I like to think of diastereomers as the trash can of stereoisomers. If you're not enantiomers, everything else will be diastereomers. So similarly, the relationship between these two compounds, those are also diastereomers. So we have 4 stereoisomers. The relationship between these two is enantiomers. The relationship between these two is enantiomers. The relationship between these two is diastereomers. The relationship between these two is diastereomers. The relationship between these are diastereomers. The relationship between these two is diastereomers. Okay, as I said, diastereomers are stereoisomers that are not enantiomers, or otherwise known as mirror images of one another. So we have 2 classes of stereoisomers. We can have diastereomers, which are not mirror images. We can have enantiomers, which are mirror images. Be very careful, because in order for something to have a diastereomer, it doesn't have to have a stereocenter. Remember, we've already said in a previous video that these two compounds are also diastereomers, right? Because they're stereoisomers and they're not mirror images of one another. So be careful, don't look for stereocenters if you are trying to determine whether or not something has a diastereomer. Okay. The last type of compound that we're going to talk about are meso compounds. Based on the previous slide, one might think that because this compound has two stereocenters, 1, 2, that it might have 4 stereoisomers. That's not correct. If we draw out all the possibilities, what we'll see is that there's only 3. Notice that we have several different possibilities. We can have this methyl up and this one down, or this one down and this one up. Notice if we take this one and try to superimpose it on the first compound, they are not superimposable. So this is a pair of enantiomers. This compound is a meso compound. Remember, we said that chiral compounds lack an internal mirror plane. Notice here that this compound lacks an internal mirror plane. We can't draw a mirror plane here, nor can we draw a mirror plane here, but we can draw an internal mirror plane here, where we can reflect this half of the molecule through to this half. This is not chiral. What's interesting about meso compounds is that they contain stereocenters, but they also contain an internal mirror plane, so they're achiral. Notice if we drew the mirror image of this compound, which would look like this, we could superimpose these on one another. We could take this molecule and flip it around, essentially like this, and they would superimpose on one another. These two are the same. So we only have 3 distinct compounds because this compound is meso, it's not chiral, it does not possess an enantiomer. Meso compounds are not chiral. They possess an internal mirror plane, which is much more clearly shown here. The definition that we're going to use for meso compounds, they contain stereocenters, but they also contain an internal mirror plane, so therefore they're not chiral. Let's look at some examples. This can be somewhat confusing. Okay, is this compound meso? As it's drawn, it doesn't look like it, but remember, single bonds can freely rotate, so you want to be very careful here. Notice, we could rotate around this bond. If we do so, we're going to get a new conformation that looks like this. So if you can rotate into a conformation that has an internal mirror plane, which we do, this is a meso compound. Okay? Let's look at another example. This compound cannot rotate, so there's no internal mirror plane. This one is not meso. This one is very tricky, so you want to be careful here. We do not have any stereocenters, right, because this group is the same as this group. We define a meso compound as possessing both stereocenters and an internal mirror plane. This has several mirror planes. It has one in this direction and it has one in this direction, but it has no stereocenters. So this is not meso. Okay, to recap, what I'd like you to be able to do is be able to identify the difference between enantiomers, which are mirror images of one another, and diastereomers, which are not mirror images. We're going to use RNS configuration to assign stereocenters, and then you want to be able to identify a meso compound by remembering that meso compounds contain both stereocenters, so you have to have more than one stereocenter, and an internal mirror plane.